I have redrawn our network diagram a little bit here. VSIX1 is on top of VSIX2, but it's the same network. There will be times when our network is not working as we expect it to be working. In order to test our diagram, we could ping from one end to the other, and that could, for example, be from PC1 to PC3 here. And that means that our ping would travel from PC1 to VSIX1, from VSIX1 to VSIX2, from VSIX2 to PC3. The ping reply would go from PC3 to VSIX2, from VSIX2 to VSIX1, and finally end up over at the PC1. That would be the ping reply. So this would be an end-to-end test of our network. If this end-to-end ping doesn't work, we could break that down into separate pings, and that is what I'm going to demonstrate now. I will bring up Workstation, and we are in PC1 now, and PC3 is also powered on, as is VSIX1 and VSIX2. So we should be able to ping from one end to the other. And that works seamlessly. I will actually introduce an error here. I will switch off PC3 simply so that it will not be able to reply to our ping requests. So back on PC1, let's try and ping again. And we see that we simply do not get any answer in any form. We're kind of blind here. We cannot see what's going on. But one thing we can do is we can start to do partial pings here. What I mean by that is that we can try and ping some of the way to PC3 from PC1. We can try pinging first this stretch here. Can we ping our gateway? Yeah, that worked. Can we ping the 10.1 IP address over here? And what about the 10.2 address? Of course, we know that this is working because we know what the problem is, but this is how you should fight your way through your network to see how far can I get. And we can actually see that we can ping all the way from PC1 to GE001 down on VSIX2, i.e. the gateway for PC3. So we now know that this and this is working all this way here. So something must be wrong in this area here. And of course, we know that it's PC3 that is switched off. It could be something else on PC3. Maybe it had a wrong IP address, or maybe we had an address conflict on this network here. I will power up PC3 again. A fundamental check to do is also to check if you are on the right IP address. If we do that for PC1 here, IP address. And what you should check here is that your iNet setting, this is your IPv4, IP version 4 IP address, that is actually what you expect. In our case here, this should be this address here on this network, the .2. I have written it explicitly down here. And important to check that you only have one iNet4 IP address. There might sometimes be lingering IPv4 addresses from some tests or experiments that you have been doing with your Linux box. Check that you only have one IPv4 address on your ENS33 interface. That's the interface we have on PC1 over here, our interface card. Another test we can do is to look at our routing table in our Linux box. In this case on PC1, I will list the routing table with name resolution and -n, meaning without name resolution. We can see here that, for example, the default gateway is resolved into 000, and the default gateway here as we know it for PC1. Test that PC1 has its default gateway correctly set to be the .1 address on this network here. Also test that the PC1 in this case has a route to the network that it's on, namely this network here, that also has to be correct set here. If there are other entries, for example, duplicate gateways, then delete them. Google on the internet how to delete routes from your Linux routing table. It might occasionally be necessary to check your ARP table. So I'll do that first with name resolution, and after that without name resolution. And we can see here that our 192.168.10.1, which is our gateway up here, the GE001 interface on our VSRX1, and that is resolved into this hardware MAC address. So sometimes this can go wrong also. So you would have to go in and check, is GE001 actually on this? Does it have this MAC address? Rarely this goes wrong, but it can happen. Some MAC addresses can linger on from earlier entries in your ARP table, for example. On our routers, we can also do some troubleshooting. So let's bring down or minimize VMware Workstation here and bring up our VSRX1 and VSRX2 terminals. We can start by listing the routing tables. I'm in command mode, so I can straight away type route, and there we have the routing tables. So go over the routes that you have in your routing table here. If we start with VSRX2, oh, that should have been changed to 2 here. That's a mistake from my, it's not a logic mistake, it won't hurt anything, but it has to be changed to 2 in order for the documentation to be correct. So the 10 network here, we have a route for that out on GE004. So that is correct, GE004 there. We have a route for the 10 network, which we find up here. And we can see that the route is via GE004. That is correct, because we want to send out on GE004 over to our router here. And it goes to the address 1 there, which is up on VSRX1. So that route is also correct. For the 12th network, which is a local network that we have right there, that goes out on GE001, GE001. Like on the Linux computers, we can show the ARP table. It can sometimes be necessary. Here in the ARP table, we see that we have the address 10.10.10.2, which is our counterpart router over here on the with the IP address 2 on this network here. So That is correct. We have this entry here in our SRX1 ARP table. And the MAC address is there. Check the IP address of that interface over on SRX2. The other entry we have is for the 192.168.10.2 address, and that is actually our PC. There is no entry for PC2 as that has not been switched on, so no ARP process has been run against PC2. Finally, we can run a show interfaces TERS. And what we learn here is that our interfaces GE001, GE002, and GE003, they are all administratively up, and the links are up, meaning we have cables plugged in, and they are configured with these addresses. So check that these parameters are all okay.